My name's Ewan Graham and I've got Natasha Smith with me. We're both members of the marking panel from last year for General Maths, and we're just going to run you through solutions from last year's exam. Before we start, it was mentioned in the methods exam that I went to earlier, but it's a really good idea if you have a read through the subject advice and obviously the reports that came through on moderation and obviously on last year's exam. It does talk in quite a bit of detail about things that were answered well in the exam and things that students maybe found a little bit harder, so that's really worthwhile reading. Okay, first question we've got here is a finance question, and we're looking at effective rates for savings on account A, which is a flat rate, and account B, which is a compounding rate. So this is something that was in the previous exam and it wasn't done particularly well, so it's come back in again last year. Just put at the side how you would do this in conversion mode within finance. So with the flat rate, we're looking at the 1 on n, with n being, the n value is the 1 on number of years. So in this case, that's 1 on 3. The I value works out as being 2.85. Somebody just shut that over, sorry. Now, the rounding here, the students were specifically asked to round to do 2 decimal places. So when you look at the solution to more than 2 decimal places, both solutions will round to 2.85. So that was quite, I believe that was quite deliberate when that was set up. The second one's compounding quarterly, so we'll get an n value of 4, and yeah, 2 marks associated with that one for each correct answer. Part B then goes on to look at, Part B then goes on to look at investment. So we're looking to find, show that the balance of the account is going to be approximately 30,100 after 3 years. So there's a couple of important points here. We've got the initial 20,000 that's been invested, so that needs to go into PMT, and we've got the weekly deposit of the $50. We need to have the signs the same there, so both should be negative in this case. However, if a student had both as positive, they would get a similar kind of answer. I've just indicated that, as you can see there, I've given the answer and then approximately equal to the 30,100, but they didn't specifically have to state that. So as long as we were getting close to the 30,120, that was okay in that case. Next part of the question goes on and looks at an inflation calculation. Okay, so this can obviously be done in a number of ways. You can do it by the method that I've shown here, indexing, 1.025 to the power 3, or you can obviously do it in TVM modes, setting PY and CY as 1 with an n value of 3. You should get a very similar answer for both of them. Okay. Part 2 of Part C goes on to looking at how much extra they would need to pay in order to buy the car in 3 years' time. So the key section here being how much extra. So the extra was quite important. So we were looking at using the FV value, using the value from C part I, the inflated value, and the original 20,000 to work out what the PMT value would need to be. And then it was just a simple calculation of the 5679 minus the original 50. So we were really looking for that 679, 680 approximately for that second mark. So the first mark would have been allocated for the calculation of PMT and the second one for the 679. The last part of question 1 looked at stating factors other than the effects of inflation that Arjun must consider when implementing the savings plan. So I've just listed here a couple, I think I've given a couple of possible answers. There was obviously several answers that we got. Most common ones that we got were to do with fluctuation in interest rates and fees and or charges associated with the account, and I've also said taxation on the interest that was earned. So what we were looking for here was one factor and then an explanation of how that factor actually impacted the savings. So hopefully you can read my writing. If we considered the fluctuation of interest rates, then a rate reduction would cause him to earn less interest, meaning it would take longer to reach his savings goal. Conversely, a rate increase would also allow him to reach that goal in less time. Yes.
Do you want students to put both parts to that?
If they put one part of it, that would be fine. So if they're looking at savings rates going up, we would look at the effect of savings rates going up, or if it was, the rate was going down, the effect on that. So it was really the factor and the effect. Is that okay? And what we tend to find in these interpretation questions, students don't really, in a lot of cases, they don't go into sufficient detail. We had a lot of students that were really looking at inflation-linked responses, which wasn't earning them the mark. So it needed to be things other than inflation, and that's really important. So they need to look at the wording of the question, and if it's specifically talking about doing something that isn't linked with, in this case, inflation, they need to be looking at another factor. Okay. All good to move on?
Can I just ask one
Yep.
question? In the very first one where you're doing that flat rate,
Yes.
that N1/3, I don't know that rule. Is that effective for all of them? Like if it was 5 years, would it be 1/5?
Yeah.
Yes.
So that was actually mentioned in the Chief Examiner's report for 2021, I think.
Yeah, but the solutions that are in the MASA guide, in terms of like questions that are in there, they haven't actually updated them to the new way of doing 1 divided by the years, and it is significantly quicker for the kids.
Oh, God, yeah. The other
Yeah.
one's like-
And that's essentially
Yeah.
why it's only
So
like
it'll
one
be
mark.
on these solutions that will go obviously into the MASA guide, but all the other questions that the kids see have all got the old method still.
Okay, but then they can go and compare it and
Yep.
see that they get the right answer.
Correct, but it's for the quantity of time that it will take them to do it. You'd want the kids to be moving on.
Can you tell Hazy to put it in their textbook?
I could try and tell them to put in many things. It might not happen.
Thank you.
No problem. Okay, question 2. So question 2 is looking at critical path analysis. Okay, so with this one, we're looking at completing a forward-backward scan. So it was a relatively straightforward network. There wasn't a lot of steps to that network. So really, correct completion of the forward scan would gain 1 mark, and a correct completion of the back scan got the 2nd mark. Mainly we were seeing errors around the dummy link, and it tended to be in the backward scan. So most people were doing okay with the forward scan. Any errors tended to be around about that dummy link, where you'd see probably from G.
Yeah, often they did 9-10 in this spot here, because they, in a sense, came back along G, but they didn't come back along the dummy link. So it's about teaching them that they have to actually go both forwards and backwards along that dummy link.
In terms of stating the critical paths in this instance, there was 2 critical paths. I'm not sure if you can see it highlighted, but I've highlighted them on the diagram there for you. So there should be the top one in yellow, and that's the ADHK, and the second one is the CJK, which passes through the dummy link as well. Part C goes on to ask about allocating extra resources to task G. Now, as we can see there from the diagram, task G isn't on the critical, it's not on any of the critical paths. So all we're looking for there is, it's not worthwhile adding extra resources to that because it's not on the critical path. It's not going to reduce any time. So any answer like that, not being part of the critical path, was going to be fine. Yes?
Is it sufficient just to say that it's not on the critical path without explaining that
Yep.
it's not going to reduce it?
Yep, it's not part of the critical path. That was fine.
So if that was for 2 marks, then you would need an explanation then, is that what you're saying?
Yeah, if it was for more than one mark, absolutely, we'd be looking for it wasn't part of the critical path, and then an explanation as to why. Yeah, but in this circumstance, simply that another possible solution would be that there was slack time already associated with that task, so that was an alternative that people could give.
Sorry, just a quick question
Yes.
about the critical path. So if they incorrectly completed the backward scan and
Yep.
didn't have to, do you still award them 2 marks for just having the one?
No.
Or is it
So if you look at the marks allocation there, that's a good guide for looking at how many critical paths should be there. So if there's 2 marks, we're really looking for 2 critical paths. If it's 1 mark, it's basically 1 critical path. A variation on that is you've probably seen in previous years asking for the number of critical or what are the critical tasks. And in that case, it might just be 1 mark awarded there because it's then encompassing more than 1 critical path. Okay. Question D is asking about slack time. Again, E isn't on the critical path. Is it okay if you just go back up to the... So we look at what's happening with E. E isn't on the critical path, but we're going from essentially the 4.4 to the 9.9. So in that case, they actually need to know the correct variation of going through to find that. So if we look at going from the 4 with the 4, that's going to take 8. So there's going to be 1 week of slack time associated with that. And I've tried to show that calculation there as well. Again, in past exams, it doesn't tend to be something that's straightforward that's asked for in terms of slack time. It tends to be something that's maybe a little bit less obvious. Yes?
Do they not need to put the other numbers around the notes anymore?
No, they don't have to. It's advised to, because then they, in a sense, can easily calculate things like slack time, but they don't actually have to. When a forwards and backwards scan, basically in a forward scan, we're looking at the first half, and in a backward scan, we're looking at the second half. Sorry, but the misconception from kids is that the slack time is just 4 take 4. They just think you've got to look at the 2 halves, and you don't actually just have to look at 2 halves when you've got 2 arrows coming back.
Yeah, so if you're looking at when task E is complete, task E could be complete after 8. So that's where that comes from. Next thing that was asked, part E, was list all the tasks that must be completed before task J can start. So it doesn't matter what order they give that in, but essentially we're looking for everything that's going to be before that. So that's going to be A, B, C, E, and F. So this section of question 2 was completed generally very well by students. If we turn over to the next page.
Just with D there,
Yeah.
if they didn't like week, do they look at the whole mark?
No. 1 I think was fine in this case. Yeah. So this next section of the question is a little bit different. So we've not really seen anything like this before. We've got the critical path, the forward and backward scan has essentially been completed, but there's no, as you can see from the diagram, I've put the numbers in on the tasks, but the students would have to go through that. So it's quite a complex question for something that it's a little bit different from what they would have seen previously. So we're looking at, with the first part, how long it would take to complete task P. So looking at the diagram, task P is going to take 7 weeks, and again, going back to what you were saying, 7 in this case was fine. How long would it take to complete Q? So they had to realise that the part of the critical path here would be from M through P from the start to the double 10s. So they've got to look at what's happening from the 10 back to the 5. So it's going to take 5 weeks there to complete task Q. These first 2 were completed reasonably well. Part 3 of F was not completed well at all. So with that one, we're looking at the latest starting time for task S, where a lot of students saying 14 because they were just reading straight off the diagram. But essentially what they had to do was they had to look at the 18 from after task S and then take that 3 off. So they actually had to work that out, that it was the 3 there from the forward scan. and the latest starting time in this case would be the 15 weeks. So as I said, this is a little bit more complex than what students have dealt with in the past. The last part of question 2 was looking at how we could reduce one of the tasks. So by allocating extra resources to one task, it's possible to reduce the overall completion time for this network to be the same as the network we had on the previous page. So this network for company Y was completed in 23 weeks, and the company X, which was on the previous page, was completed in 20 weeks. So we're looking at a 3-week reduction. So state the task and the reduction time required to complete this. Okay. So if we go back, if you don't mind, if you just go back up to diagram, sorry.
Oh, good.
The only one that's actually possible in this case is task R. Okay, there's no other task that will allow a 3-week reduction. Okay, so they had to say that it was task R, and they had to say that it was by 3 weeks. And then the next part of the question, they had to then explain why that was true. So I've given quite a detailed explanation as to why that's true. We didn't, sorry. I've given quite a detailed explanation as to why that's true. If you look at the sections of the network, if we look at the STU section, you can only save 1 week from that section. If we reduce either S or T, you're only going to save 1 week. If we look at the initial part of the network from the 00 to the 1010, we've got one section that's taking 9 weeks and the other section's taking 10. So again, you're only saving 1 week in that proportion of the network. So they had to get across, and this was quite complex. They had to get across that middle section was the only place that they could save that time. Yes.
From the explanation there,
Yeah.
would indicate that it's potentially more than one marker. So how would you mark that?
There needed to be a certain level of explanation there. It was, as I said, it was quite a challenging question.
A little bit I would say misleading for students if they're saying they've got to give at least some kind of analysis behind that path length, why they've chosen it.
Yeah.
Surely there will be the 2 marks allocated for that.
But you could, at the same time, if we just look at task R, we can talk about the fact that there's no other parallel path through that, and therefore that's a must-do task, and take away 3 and we're done. So it also can be done very quickly.
Yeah.
And hence.
But there's that justification you're saying why I've chosen that path. If you're saying when
So
you're
I've gone into a lot more detail.
Yeah, he's gone into much
answer.
more detail, so you guys have got detail about what we're sort of looking at.
But essentially what
Yeah.
Natasha's just talked about there, talking about the fact that task R was the only one that was
Yeah.
possible, that was enough, or that was sufficient for that mark.
Yeah, you could have, in a sense, got away with that first part of the sentence and then
Yeah.
stopped. It's just that we wanted a bit more detail,
Yeah.
so that teachers are aware of, what they could discuss if they wanted to.
Yeah.
How many were we on the language? Did you say like if bottlenecks at R, at task R, or
Say that one again.
if a student said if bottlenecks at task R, task R must
Never
be-
saw it.
Task R must be on the critical path.
Sort it out then.
Yeah, I
Yeah,
didn't
look,
see that
if
kind of
we
language.
felt like
but-
they had enough idea, it would be. But that response, not one student out of the ones I saw gave that answer. And
Yeah.
it was a question they struggled with, because they often just sort of, they naturally just grabbed a task that was on the critical path, not necessarily really thinking about why it had to be just a particular task. Yeah.
But essentially, I mean, if they're looking at the network and they're seeing that task R has to be on the critical path and that one there, so the first statement that I've made there would be sufficient. Yeah. Any other questions about that one? Okay, let's move on. Question 3, normal distribution. So we've got various varieties of scented candles. Now I was hearing from a couple of my students this year that apparently there was lots of memes happening about scented candles on SAFE discussion pages. Who would have known? Yeah, apparently. So the first question there is calculate the probability that a vanilla scented candle will have a burning time of less than 238. So we're just looking at a lower end probability calculation there. So I've put up the inputs for your graphics calculator, and we're just looking at the p-value of being 0.242. Okay, so they didn't necessarily have to put the inputs in. They didn't necessarily have to show us them, but we're just looking for that p-value. And again, I think we accepted going to 2 decimal places there as well. So 0.242. 0.2 wouldn't be sufficient, okay? So they need to go to minimum 2, but ideally we're looking for 3 decimal places there. Next part just follows on. So if they'd made an error in the calculation in part AI, then we would follow that through. So we're just looking to do the multiplication by the 5,000. One thing I want to highlight there was that we were actually looking for a whole number. So we're looking for an integer as a solution. Because we're dealing with candles, we wouldn't be expecting people to sell half, or we wouldn't be producing half candles. So we're looking for an integer solution in that case. Yes?
Just to settle an argument amongst myself and my colleagues, would you have accepted P is 24.2%?
I think we did. Yes.
Thank
Yep.
you.
Yes. Part B. So we're now looking at the company expects to receive complaints from customers who have purchased candles with the shortest 10% of burning time. So we're looking at an inverse normal calculation here. Tails on the left. If we had tails on the right, then there was follow through based on that. I can't remember off the top of my head what the solution was for that.
But they still got 1 out of 2.
They would have got 1 out of 2 if they had the tail in the wrong place. So with time being a continuous variable, 226.37.4 was acceptable. Okay. Fairly straightforward. Yes.
Can you give me an idea of the typical convention, the rounding convention? So, for example, is it like a 3 sig fig or 2 decimal place, whatever's appropriate? Or is there a set convention that you're choosing?
We don't
In
have...
stats, we usually say to kids, I would be recommending my kids to go 3 decimal places because your numbers are quite small, if that makes sense. But in terms of when you come into the exam, we really are trying to give the students marks. So if they've gone to 2 decimal places, we're like, well, they've got it right. They knew what to do, so they would. Where
Obviously beneficial for money, where you get a finance at 2 decimal
yeah,
places.
correct. That's exactly. In finance, we're less worried about decimal places because it's a small change to a number going in a calculator makes a massive difference to what those decimal places are. Whereas in stats, it makes a difference. And cutting that first one back from 0.242 to 0.2 is very different. So we kind of go, well, no, that's 4%. That's a bit much. Yeah. So stats is probably where we worry about them having a few more decimal places. But we would follow through wherever they go. It becomes follow through. If they give us a different amount, we just keep going.
Okay. So we've then introduced on the next page, we've got, I think it's rose-scented candles come up next. Yep. So we've got rose-scented candles, and there's been a claim that, so the company claims that the greater proportion of rose-scented candles will burn longer than 300 minutes. So I've shown here a calculation based on lower tail being 300 for each one, and we've compared the probabilities. If you look at the vanilla scented candles there, you get a scientific notation solution, so 8.20 times 10 to the negative 3. If the students if the students used that, that was okay. If they used what it said in the calculator, which was, I think, 8.2 e minus 3, that's not okay, because that's not scientific notation. So scientific notation in that case is all right, and we accepted that, or we would accept the 0.0082. That was all right as well. They could also have found, instead of looking at that upper section, they could have found what was less than 300 and compared those two probabilities as well. So either way was acceptable. So they had to find probabilities for both rose and vanilla, and then they had to make a statement on whether the claim was correct or not, with a valid justification, and something like that would have been fine, or saying it in words was okay as well. Okay. We then have the graphs, or the distribution graphs. So what we were looking for here was a third variety of candles. So you've now got rose, lavender, and vanilla. And we're just looking for them to be put in the correct place. So I think we had 2 that had the same standard deviation and 2 that had the same mean. So if they got if they had 1 correct, that was 1 mark, I believe, and all 3 correct got 2 marks. And I think we accepted if they just had R, L, and V as well.
Sorry, I
Yes.
had a debate with a colleague. A colleague said, identify the probability distribution. Is that not stating the mean and the standard deviation as opposed to the name?
We
We
accepted
accepted
that
that
as well.
Yeah.
Yes. So
Yeah.
at
So
the end
the-
of the day, they're indicating which one's which. We're happy with it.
Yeah. So if they gave us the mean and standard deviation in each box, we accepted that. Yeah. D part 2. Explain why the maximum height of probability distribution A is lower than the probability distributions B and C when considering the properties of a probability distribution curve. And that last sentence there is the key part in this question. Okay. A lot of students got 1 out of 2 for this question because they talked about the difference in standard deviations. But that second point that was made there, the area of all 3 curves must be the same. So if we've got one that's wider than the other ones, it's got to drop lower. So they had to be talking about the area of the curves either being equal to 1 or being equal the area under each one being equal. And that was the key point that we were looking for there.
I didn't think we ever worried about the height of it when we drew it. We just worried that they got the ends in the middle right.
Well,
Now
we-
we're thinking
no, we-
also-
No, the
In past
heights.
exams.
Yeah, so this
Yeah.
has been assessed in different ways over the years. There has been examples of like one distribution curve being drawn and then another distribution curve having to be put onto that. And again, I think they were worth 3
Yeah.
marks at that point, and the height, the placement of the height was really important. So it's something that's been assessed quite a lot over the last few years.
I didn't think they were worried about the height, they just worried about being in the middle and the ends.
They certainly did worry about the height.
Yeah.
There was a certain give way between where the height had to be, and they said, well, here's a bit of flexibility within that. But they needed kids to understand that,
Okay.
yeah.
Yes.
So you said that specifically area needs to be discussed and mentioned.
Yes.
Did they need to use the word area, or could they have described it without using the word area?
I don't think we saw.
I don't think we saw many that did, like those that got it basically had area. I can't remember anyone getting it without using the word area. To be
And
honest.
I mean, as I said, we accepted equal or being 1.
Yeah.
So the area under the probability being 1. Okay.
But that was certainly a question that students struggled with to get the 2
Yeah.
marks.
So that was one of the questions that students found really difficult,
Yeah.
that second part, and gaining that second mark there. Okay, next question, Hungarian algorithm question. This question was done really, really well. I can't remember the exact stats off the top of my head, but there was a very, very high percentage of students gaining at least 12 marks out of the possible 14 in this question. It was certainly the one that was done best out of the entire paper, which was really pleasing. So we've got a situation where we've got 4 children and they've got weekly chores, and we're looking at initially just pulling out the correct interpretation of what 19 represented. So it was to do with Bobby taking 14 minutes to fold laundry. Again, another interpretation question in B, based on the information above, which child is the fastest to complete the dusting? So again, just pulling out of the table, it would be Joe. Calculate the total time it would take Kelly to complete all 4 chores. So again, with this one, we were just looking for the addition of those 4 values. The minutes in this case was important. So we were looking for them to display reference to minutes either in Part C or in Part D2. Okay, so they had to refer to minutes somewhere in this question. So either at this point or when they actually calculated the total minimum time. So most students, as I said, did really well with parts A, B, and C. The next part is looking at the algorithm. Yes.
So before we had the one with regards to weeks,
yes,
where it was like 1 week or 3 weeks, but that didn't matter. And it was still only 1 mark, whereas this is still only 1 mark, so you're expecting to do minutes.
So there was, in terms of this question, there was a couple of opportunities for them because so in previous questions on Hungarian algorithm, we've looked at units. Okay, so there's no, in this question, there wasn't any multiplication factors or anything like that. So it was purely just looking at the minutes. So we were looking to we were looking at, with this question, to be quite specific about showing it somewhere, whether it was in Part C or at the end. And I don't think I came across any students who didn't put down minutes, to be honest, when I was marking.
It's more just that in that other place you didn't care if they had it or not. Specifically saying this question have to have it.
And I think because we'd harped on it, they'd been harped on in previous exams, like there's always been the moment where they should be able to, in context, look at the Hungarian algorithm and know what time frame it is. So it was just where they decided that they needed it again. And they are, to be honest, they're the easiest questions of the paper. You know, so kids are getting really good marks here.
Okay. In terms of the completion of the algorithm, it was done really well. So we've got completion of the rows first of all, then the columns, and with this one you had 3. You can't quite see clearly there, but I've used the highlighter to highlight the 3 columns, so across the top, down the far side, and in the second bottom row. The red sections, the 4, 4, 5, and the 3, 4, 2, 4, they need to get the 2 taken away from them, and the other boxes where we've got the double crossover of the lines, they need to get the 2 added on. So in terms of how we marked this, we were looking at correct subtraction of the rows, then correct subtraction of the columns. We were looking to see lines somewhere, and then that last process of the addition and subtraction. So the interpretation didn't actually come until the next section, which was where we're looking to allocate the tasks. So where we saw that last completed, can you scroll? So that last completed step didn't actually have to be shown to get marks for DI, but they would have to have that somewhere to help them with DII. Okay. So again, all we were looking for was the chores. You didn't need to list the numbers down the side, but it was obviously helpful if they did. And in this case, we were looking at 1 mark for the correct allocation and 1 mark for the correct time. As I said, most students were doing really, really well with this. Okay, so we've now got the children's fathers coming in to help with some of the chores. State why a dummy column of zeros must be added to the right of the dusting column in order for the Hungarian algorithm to be applied. You can't apply a Hungarian algorithm if it's not a square array. So any mention of the fact that it needs to be a square array was sufficient for them to get the mark there. State the member of the household who will not be allocated a chore. So looking at the allocation there, they would obviously need to look at the zeros and the placement of the zeros, and it would work out that Paula would be the person who wasn't going to be allocated. Final section, state 2 limitations of using the Hungarian algorithm to allocate weekly chores in the context of this question. Now, this was done really well, and I think it was done well because students could relate to what was happening in this scenario. It was to do with weekly chores. They've probably all come across something like this before. So they came up with some really good limitations for this. And although I've put 2 down here, there was a lot of things that we accepted, and there was a lot of common sense things that were accepted here as well. So the Hungarian algorithm does not allow for chores to be shared or completed by more than one person. So I mean, that's something that would generally happen. People might share a job and take less time to do it. So the Hungarian algorithm doesn't allow for that. Some chores may need to be completed more or less frequently than weekly. Okay, so again, something that's probably going to happen in most households. People are going to maybe have to look at folding laundry more than once a week, I would think, so, or vacuuming more than once a week. So practical things like that we were happy to accept. Does anybody want to ask any questions about that?
Yep.
Okay.
Hold on.
Yep.
Were things around like fairness accepted? So like
yes.
maybe father should be doing more than just one, or should not?
Or the fact that the other children would be extremely upset at the fact that Paula was getting away with doing nothing. Yeah. Yeah. That kind of thing.
So like it was beneficial to be bad at chores so you're not allocated to chores?
Correct. Yeah. Okay. Question 5. We've got a home loans question. So this was quite a short question, but the last section was a little bit more complex. So within this question, we've got a home loan of $650,000 over 20 years. And we're looking to show, again, we're looking at a show that section. And the reason why we do those show that sections is so that students, if they can't do that first section, they can then continue on with the rest of the question. So again, similar to what we had in the earlier question on financial maths, if they're getting to, if they didn't give us the decimal places, say they gave us 3,565 or 3,566, they've done the right process in their calculator. So I've written down what the calculator inputs would be. So we're looking for that process and we're looking for that correct answer there as well.
And they can backward engineer it. So they could put the payment in and work out, for example, the PV, and they're still going to get their marks as well. They don't, there's multiple ways to get it, showing us that.
Can I clarify that it's the inputs that are needed in addition to the result? So it's not sufficient for the 2 marks that inputs are given and then just the approximate result?
No, they can't give the approximate results. So they would need to state what their calculator gives them.
They need to have that 3,565 there. Yep.
Yeah.
Sorry, could you just clarify what you meant about going backwards?
So, for example, some students decide to put their payment in as 3,570, but prove that PV is approximately 650,000.
Yeah.
So, and it happens every year. They just decide they're going to show a different one. They can also show N that ends approximately 20 years.
Or they can show the I value as well.
So it's just a matter of them going, well, I have an alternate way of showing that this is in fact appropriate. And we don't disadvantage them because they've still shown us that.
No, it's a little bit different. I mean, that's what we're expecting to see, but there are various different ways that they can get the marks. The second part of this, so we've used the amortization. So with this one, we're looking at the total interest over the 20 years. So with this one, if you use amortization, PM1 is 1, PM2 is 240, and that gives a sum of interest of 20,583.11. You could obviously do the longhand way of doing it. That's perfectly acceptable as well. The space that's allocated here, okay, obviously you don't have a lot of space, so we're trying to encourage people to use amortization. It's a much more straightforward way of actually calculating this. After 5 years, Keisha's balance is reduced to 520,700. Interest rate increases to 3.6. So what we're looking to do here is calculate how much longer it's going to take to repay that loan. So we're looking at an N calculation. So we're looking at interpreting the information that you've got from obviously the question there. So the PV value has to change. We are using the value that you've had or been given from the first part of the question. That's why we had that show that section initially. So while we've continued on with this, if you use 3570, that was perfectly acceptable as well. It will give you just a slightly different n value, but that was okay. We would follow through with that. So n came out at 192, which was going to give approximately an extra 1 year or 12.4 months. Okay, so in terms of marks allocation there, we were looking at the extra 12.4 or the extra year. I think we accepted an extra year. Yep. The n value, and then the correct setup of the calculation with obviously the changes that had been made.
Just hold on, question.
Yes.
All good. That's through you.
I just wanted to ask you said that they could put in the 3570.
Yes.
If they calculated a more exact answer, was the 3570 still accepted?
How do you mean a more exact answer?
So if they had worked out the 3565,
They can use any from that point. So they can, in a sense, have 3565 in the first one, but then go to 3570 going forwards, because often it's easier to input for the students. They can take either.
Yes.
Yeah.
But they would probably have that in a calculator anyway. Yes.
So you weren't worried about the rounding whatsoever? So like,
The problem you have is, and I'm not sure how much you've done it, but as soon as you change that rounding of 3565 to slightly differently, it's just a flow-on effect, and you can't. As a marker, we're not expecting them to put in everything just to make sure it's correct. So that's why with finance, we're less worried about the decimal places at the end, because as soon as they, because a lot of kids actually just leave the 3565.96 plus all the other digits. Well, we don't know how many they've left there. So you can't really, as a marker,
so
yeah.
Also with the answer, we're going to send 13 months?
Yes.
Yeah, correct.
The other thing that happens as well is some students use beginning mode instead of end mode. Now, while end mode is what you should be using, yeah.
Yeah, we're after the process.
That's correct. So, within the marking scheme.
I've lost the.
Within the marking scheme, we look at what's happening within beginning mode and end mode for all those finance calculations. Because there is a slight variation in it.
So it's okay to write 193 and use that? Is that what it means?
Yep.
Yep.
193.
Correct. We're looking at the process, absolutely.
Yeah. All good? Okay, last. Yep, sorry.
At this stage, you're not penalising for units, whether it's months, years, you didn't mind. If they said 1 year.
No, 1 year was accepted.
1 year was fine.
Yeah, correct.
So one year or, we would have been looking at months. So if they said 1 year, that was okay, or if they said the 12 months, that was fine.
So we're completely disregarding the 0.41 means that it's not paid off, which is how it's always been taught, that they have to round up the finance.
Yes, we're disregarding that.
However, you probably don't want to teach them that.
You're not going to teach them that, but in the exam, we're there to find the kids' marks. And at the end of the day, in an exam pressure situation, are they honestly always going to round up? Because if we did that, they would probably use 10 marks in the whole paper. And that's not fair to these kids. Like, that's reality. But you're right, in my classroom teaching and in my test teaching, in my assignments, absolutely I'm going to hound on them. Okay, but in this situation, no, we're not. Okay, I think these kids doing a 2-hour exam and all the things that have to and getting it finished is enough.
So you're accepting 12 months or 13 months either side?
Final part of the question, again a little bit different. So with this one, we've said at this time they're going to deposit a lump sum. So to calculate the size of that lump sum. So what they had to do with this section is look at finding the principal value. And then they're looking at finding the difference between the 520,700 and the principal value that they've just calculated. So as I said, not done something, I don't think there's been anything like that previously, so it's just a little bit different. And I don't...
It was a half-half. A lot of kids were getting 43,000.
Yeah. So
rather than 25.
It wasn't done brilliantly. Okay. Stats question, question 6. So we've got table below shows observations of Arctic sea ice from 1980 to 2020. And we're looking at using correct variables. We would like to state the equation of the least squared regression line, the line of best fit, in the form y equals ax plus b, but obviously using correct variables. So with this one, we're looking at s is equal to the negative 0.082d plus 169.63. Now, if we had variations on the decimal places there, that was okay. The s and the d we were looking for in the correct place, and that was 1 mark, and the correct a and b values in the correct spot was also that second mark there. Part B, complete the statement below. The numerical value of Pearson's correlation coefficient R for the linear regression model is, so we're looking for the R value there. The negative was important, okay, because it was a negative relationship. And the 0.797, if they gave us negative 0.98, that was okay. But if they gave us -1, obviously that's not okay. This suggests that the year of as the year of observation increases, or as they could say time increases, the area of Arctic sea ice will decrease. So we're looking for the two variables in the right spots and the relationship there. Next part of the question on the next page, we're then going on to have a look at a residual plot. So we've got 1 point that's missing from the residual plot, which we've plotted in there. So we were looking at, first of all, calculating that value. So that value comes in at 0.199. I think we accepted 0.2. And we were just looking for the correct positioning of that on the graph. So that's been plotted, and I've just circled it as well for you. From memory, that was done reasonably well. Next part is then using from your equation. So if they gave us a different equation from part A, there would be follow through there. So using your equation, predict the year of observation when Arctic sea ice will be 1 million kilometers squared. So in this case, we accepted 2055 or 2056 based on the model that I've given you. Obviously, if students have given us a different model, then we might have some variation on that. But as I said, we would follow through based on that. Again, in this, because it's asking for the prediction of the year of observation, we're not going to accept a decimal solution there. So it needs to be a year integer solution there. Discuss the reliability of the prediction made in D part 1. Give 2 reasons for your answer. Okay. So what we were seeing there was, it's obviously an extrapolation, and the extrapolation is quite far from the actual recorded information. So you're looking at 35, 36 years into the future. So talking about the extrapolation with reference to that, that would be sufficient for 1 mark. So that would be one reason. And then they could go on and talk about other factors, external factors. So one thing that we saw a reasonable amount was to do with climate change. Human factors, looking into reducing that so that hopefully that wouldn't get to 1 million square kilometres. As I've said in the solution here, you could also say that the prediction should be reliable as the R squared value is strong. Okay. Line of best fit was good, and we had a random scatter in the residual plot. So that might be sufficient for 1 mark as well. So if they said that, they could then argue about the extrapolation as well. Okay. So there's a few things we could accept in that circumstance. Okay. Yes?
Sorry, the 2 marks, because you're essentially having 2 contradictory ideas there.
Yes.
Because are the 2 marks allocated for the
so
2 reasons?
If they said extrapolation based on a long time in the future, they would get 1 mark. If they then backed it up and said something along the lines of to do with climate change and they hoped it wouldn't get to that level, that could get a mark as well. If they talked about the strong R-squared value and the good random scatter, that was also worth 1 mark. So they could talk about different things.
But you're looking for the reliability,
Yeah.
so whether
they
there's
would
or
have
is
to
not.
mention the reliability.
Yeah, but
based on
then
that.
2 marks, because I feel like it's almost 3
There's
marks.
never been marked for a while, given to the statement of it's not reliable or it's reliable. That went out of good 4 or 5 years ago.
Yeah.
And so we say, well, that's no longer a mark. What the marks are coming from is your discussion about the choice that you made.
So the 2 marks, you could actually contradict yourself as long as you give a reason for each.
Correct.
Yes,
Right, or
correct.
you could give 2 reasons to support
Yes.
the unreliability.
Yeah, it's about your reasoning.
Right.
Yeah,
But
absolutely.
we had to still talk about it being based on that being reliable or unreliable.
Right.
Okay. Yeah. Okay, let's move on. Question 7. We have a network problem. How are we going for time?
I don't know. We've just gone an hour.
Okay,
So we've got
cool.
about 30 minutes.
Question 7. So we have a precedence table shown there, and we've got a diagram that's been partially completed. So this one has 2 dummy links. It's got 2 tasks that have been missed out, and the students were expected to correctly place task D and task E into the network. So doing that the correct way around got them 1 mark. They were then expected to explain why dummy link X is required. So this is only a 1 mark question. We were looking for task C requires both A and B to be completed, and task D and E only need B to be completed before they can start. So there was a relative amount, quite a lot of detail required there, but it was important that they talked about each of those tasks, because otherwise it's not a complete interpretation of the problem. Part C was looking at which option correctly identifies the critical path and minimum completion time. Now they could get that from the table. If they look at the times that are, so where they've got the earliest and latest starting times matching, that's going to give them their critical path. And if they remember to add on the 2 hours from task J, which is the last one, then they're going to get their 19 hours. Okay, so that was worth 1 mark. The final part was 2 marks. Now, they were to tick the box or boxes to indicate correct answers. In this case, it's similar to the question that was asked earlier about the critical paths, and if there was 2 critical paths and 2 marks, or 1 critical path and 1 mark. There's 2 marks here, so we were expecting 2 boxes to be ticked. Okay, and you can read through the options there. 3 of them just don't make sense, and it's those 2 that are obviously correct.
But kids are still struggling with multiple choice questions. They could often get 1 out of 2, but getting 2 out of 2, they tick 2, but they often didn't get 2 correct. So they, in a sense, only were getting 1 out of 2. And it's just teaching them about how to approach multiple choice questions and reading very carefully.
The other thing that's important here is if they ticked like 3 boxes, because there's only 2 correct answers, they can only get, if they tick 3 boxes, they would only get 1 mark. Okay, so if they give incorrect solutions, so they can't just tick every box and get 2 marks. Okay, they have to realise that in this situation, it's worth 2 marks. It's two solutions. If they give 1 and it's correct, they get 1 mark. If they don't give any, they get no marks. If they tick 4, they're not going to get any marks. Okay.
And the common one, like kids don't necessarily read the whole line. Like they've often read task J will always be on the critical path. Oh yeah, that is, they tick it. They don't read the second half. And the second half statement, that's wrong. So it's about teaching them to read the whole bit and critique the whole thing.
Yeah. And this question was done reasonably well. I think we were seeing most students get about 4 out of 5 for this one. That was probably the most common mark that I saw when I was marking. So about 4 out of 5. The explanation of the slack time, explanation of the dummy link was probably the thing that was done worst. Okay. Okay, our final question on finance. So we're looking at another loans question. So we're looking to purchase a small apartment. We're looking to borrow 280,000 over 15 years, and we've got two options. Okay, so we have to calculate the comparison rate for option A. So with this one, because there was an establishment fee, that had to be added on first. So we then had to calculate the PMT value. So the calculation of the first PMT value of the 95327 got the first mark. Then adding on the $15 to show the new PMT value got the second mark. And then removal of the establishment fee, calculation of the I value, that got your third mark there. Students who used the old Maths Apps method for this, with preloading all the fees at the start, could only gain a maximum of 2 marks, because that method is wrong, and it's been talked about in the subject outline as being wrong, and I think it's been talked about in the Chief Examiner's report for the last, every time this question's been up recently. And that's basically, it's an old method, it's not the correct method. If your school's still using the old Maths Apps textbooks, that's the method that's taught in there, and it's the incorrect method. Okay, so this is the method that any time we've got a comparison rate calculation, that needs to be done to get full credit. Part B, we've got another multiple choice question. Which statement most accurately describes the best option for Olivia? So it was the third one. Option A is the best, as it is the lowest comparison rate. Now, if they'd made a mistake, obviously, in part A, then there was other solutions that would be appropriate there. So this was set up so that there would be follow through possible. Olivia chooses a different option where she pays a deposit of 50,000 and takes out a loan for the remaining balance. Her weekly repayments are, so we're given the weekly repayments for 15 years, show that the interest rate charged on the loan is approximately 4.1. So with this one, again, similar to, I think they could reverse engineer this one as well, couldn't they? Yeah. So the key points here are taking off the 50,000. So we had quite a few students who forgot to take off the 50,000. There's a few things that have changed from the original part A. So essentially we're looking for, again, the correct setup with this one, the removal of the 50,000, and then the calculation based on I. Any questions about that? Yeah. Yes.
The one before question B.
Yes.
Say they did make a mistake on question A.
Yes.
And it was for another reason, like a different option was better.
Yep.
But they say they looked up, they saw the person on the other side tick the middle box, and they decided to tick the middle box as well. How would you mark that?
0. Because we don't know that they've done that. It's as simple as that. Yeah. And the other thing is, if they don't attempt anything in A, then we can't make any comment about B. They kind of lose that automatically, because again, we just don't know where they've come from. Yeah, not luck of the draw.
No. Yes.
So with part C, because it's to show that, I'm just trying to support the mark how we're doing a test. You know, 1 mark we'd want to show that 50,000 taken off the 280.
Yeah.
Would you give a second mark for the rest of the input? Like, how would a student get 1 out of 2 marks there?
They've put all the inputs correctly, but they've got 1 mistake out of those 7 spots. So, for example, they've put it all in, but then I is different, a different answer. They have put 1 incorrect. So let's say they did a different PV, but then calculated I, and they got I to be slightly different. And let's say they got I as 4.2. Oh, sorry, 4.2. Then their mistake is actually earlier, so it becomes a follow through. So it's kind of like 1 mistake, but it's the similar mistake. So certain things are connected. Like for example, PY is kind of connected to N. If they've changed from 52 to monthly, well then you're going to expect N to be monthly as well. So that's still only 1 mistake. Yeah. Because it's 1 understanding that they've got wrong.
Right. Okay. Thank you.
Yeah.
No worries. Part D, we're then asked to calculate the time it would take for the balance in the loan to reach approximately half of its principal value. So we're given half the principal at 115,000. And with that, based on the calculations that they had with the 4.1, if they didn't get 4.1 from the previous section, they'd be expected to use that. We're looking at 449.6 in terms of weeks there. So just 1 mark there for finding the N value. And then we've got a next section to the question where when the balance of the loan is reduced to 115,000, Olivia receives an inheritance that would allow her to pay the loan off in full. Her financial advisor presents her with the following options. So we've got option X, which is repay the loan in full immediately, but there's an early repayment charge of 11%. Or option Y is refinance the loan for 6 years with interest charged at 3.5 compounding weekly with no additional charges. So part E is essentially getting to calculate that early repayment charge. So that's just the 11% of the 115,000. Relatively straightforward. And then the next part is calculate the total interest that Olivia will be charged if she chooses option Y. So with this, you first of all have to calculate the PMT value, and then it's a sum of interest calculation. Okay. So obviously got to set up that question again. So you're looking at finding the PMT, that comes in at 408.77. And because you've already got all that information in your graphics calculator, you should then be able to just use the amortization PM1, and then PM2 is the 6 times 52, which is your 312 to get your sum of interest. Okay. Option 3, sorry, not option 3, part 3. Olivia chooses option Y and deposits the 115 into an offset account linked to option Y. State 2 reasons to explain why this is a reasonable decision. So we've got a little section on offset accounts here, so it's just really looking at what are the features of offset accounts. So she'll have access to the money instead of spending it on her home loan. She'll save approximately 12,500 charged in interest, provided she maintains the balance in the offset account. So that's really all we were looking for in that case. So just really looking at the features of the offset account there. Okay. Anybody want to ask anything about that? Did we accept anything else there?
Not that I can remember. They were the two things that I think there was one other, but
they were the main two things.
Yeah, they were the main
accepted.
two. You kind of read the answers, and you sometimes had to make that judgment about whether they were showing enough understanding of. Yeah, so not particularly if it was just on a case by case. But they were the main two.
They were the main two that we were expecting.
Would you have accepted you don't pay income tax on any like interest generated?
I think we would have accepted
that.
that.
We would have accepted that, because...
Yeah, so there was a taxation component,
Yeah.
Okay, last question. So we've got another medication question. We've got medication V, it's administered into the bloodstream, and we've got a table of recorded values. We have then produced a linear model equation, line of best fit equation, given an R squared value, and there's a residual plot being produced for a linear model. So using the information above, so there's obviously a lot of information above, explain why the linear model is not appropriate to use for making predictions from the data. So the most obvious ones are that we've got a clear pattern in the residual plot, and we've got high residual values. Okay, so they're the most obvious answers that would be accepted in that case. Does anybody want to ask anything about that? Yes?
Maybe something to do with the R squared.
Well, in this case, the R squared value at 0.8 is considered to be okay for making predictions. So we wouldn't really accept anything to do with the R squared value. I think the R squared in the subject outline says that as long as it's above 0.7, then it's okay for making predictions. Okay? Yes?
It doesn't specify to give two different points. Do they need to get the 2 marks? Do they need to? Yes.
Because it's worth 2 marks, then they should really be making 2 points in that case. Yeah.
And often teaching your kids about the mark, like marks, see them look at the marks, that kind of is often an indicator of how many, how many things you need to give, Yeah. Yes. I think because it's an explain, so often an explain automatically has to have 2 because you're needing to give more detail, like more reasonings to why it's not a good model. Otherwise you might go, well, is one reason good enough?